Okay, welcome back, and now we're going to do some examples of finding the integral, the indefinite integral for more complicated looking functions. Now some of these we're going to be able to use the properties, some of these you're going to have to manipulate to look like one of the common derivatives that we've been working with, okay? And some of them you're just going to have to kind of, I guess, yeah, like I said, manipulate, rearrange, rewrite, whatever the case may be, okay? So let's jump right in. So here we have a polynomial, and notice that it's these terms connected by plus and minus, so we're going to use the properties, the sum and difference properties. So what does this mean? It means that I can write this as what? I can do this term by term. Okay, so I can find the integral of 5x cubed dx minus, right, the integral of 7x squared dx plus the integral of 3x dx plus the integral of 4 dx, right? And so basically I can take the antiderivative of this, this, and this, and then add and subtract, right? So that means that what do I get? I get the antiderivative is going to be what? Well, this is, so they're all indefinite integrals, right? So they're going to end up with a constant on this one, a constant on this one, a constant on this one, and a constant on this one. But that's okay because we can pool all those constants together into one constant c. And that's what we're going to do. So I'm going to save all the constants to the end. So it's going to be 5x cubed. So I'm going to pull the constant out. So I'm going to use the power rule and the constant multiple rule. So that's going to equal 5, and the power rule says increase the power by 1 and divide by the new power. So this is going to become 5/4 x to the 4th minus 7/3 x to the 3rd plus 3/2 x squared plus 4x. Right? And of course, plus c. And that is the antiderivative. Okay? Now, what about this one? Well, here, I'm going to rearrange this and simplify this by making this into two terms, right? So I'm going to divide both terms here by x. So this is going to be the integral of x plus what? This is going to be 4x to the 1/3 divided by x, and I'm going to make this into, instead of a 1, I'm going to make this 3/3, right? Oh, wait a minute, I dropped my dx. Don't drop the dx. Okay, and so this is going to be dx, and then this is going to be equal to, now, I'm going to put the integral sign, and this is going to be x plus 4. Now, if I subtract, what am I going to get? I'm going to get negative 2/3. So this is going to end up being 4, oh, hold on, 4x to the negative 2/3 dx. And now I can do this term by term. And so what happens? I get the derivative, the antiderivative, or the antiderivative of x is 1/2 x squared plus, I'm going to increase this by 1, right? Which makes this 1/3, and then divide by the new power, which makes this, I'm going to multiply by 3, right? So this is -2/3. So if I increase this exponent by 1, so I'm going to add 3/3, which makes this positive 1/3, and then divide by 1/3, which is the same as multiplying by 3, I'm going to get 12x to the 1/3 plus c. So my final answer would be 1/2 x squared plus 12 times the cube root of x plus c. Okay. Now, the next one. So now the next one, we're going to have to rearrange this one because, one, I cannot break this up into two fractions, right? You cannot do that with this one, okay? Okay, so now, what I need to do is I'm going to factor out the 4. Okay, now, you need to recognize this as the derivative of inverse tangent. You need to recognize this. If you don't recognize it, your life is going to be harder than it needs to be. Okay, so this is the derivative of inverse tangent. So the antiderivative of this is inverse tangent. So this would equal 4 inverse tangent of x plus c. That's it. Okay? It's just a matter of recognizing this from the derivative formulas. Okay? Again, so you should be memorizing and studying the derivative formulas. Okay, now this one here is actually looks complicated, but it's really easy. Because all I'm going to do is use the definition of these trig functions to simplify this, right? So I'm going to write tangent as sine over cosine. Okay? And now look. The cosines cancel, and it just becomes the integral of sine x. And so the derivative of what function equals cosine, or excuse me, the derivative of what function equals sine? Well, that's going to be negative cosine. So this is going to equal negative cosine x plus c. And that's it, guys. Have a great day.